Hi to all. Today's topic is energy density of electromagnetic wave. Energy density of electromagnetic wave. What is energy density? And what is the formula for energy density of electromagnetic wave? That I am going to explain. Let us see here. Energy of EM wave equally distributed among electric and magnetic fields. Electromagnetic wave has oscillating electric and magnetic fields which are mutually perpendicular to each other and also perpendicular to the direction of propagation of wave. Here the energy of EM wave distributed equally among electric and magnetic fields. Energy density of EM wave I want, that means energy density electric field will be there, energy density in the magnetic field will be there. If we add the electric and magnetic, then we will get the electromagnetic wave energy, right? That is, first I am going to write the average electric energy density. Average electric energy density means energy density in electric field. Its formula, that is, we know already, of epsilon naught E square, right? This is the formula. But one thing we know, that electric field is varies in electromagnetic wave, oscillating electric field. That's why here we have to take the RMS, ERMS, okay? And magnetic field, average magnetic energy density. Energy density means what? Energy per unit volume is called as energy density. Average magnetic energy density. Magnetic energy density is the magnetic energy per unit volume, that is denoted with UB, that is the energy stored in, it is equal to energy stored in the solenoid. Energy stored in the solenoid. This is equal to energy stored per unit volume in electric field means that is equal to energy stored in the capacitor per unit volume. Energy stored per unit volume in the capacitor, this formula will be there. Magnetic energy stored is half Li square, or we can write B square by 2 nu naught, but the B RMS square by 2 nu naught. This is the formula for the electric energy density. This is the formula for the magnetic energy density. I want the average energy density of EM wave. I want average energy density of EM wave. EM wave means electromagnetic wave. That is the sum of electric energy density and magnetic energy density. That means we write U is equal to UE plus UB. In this we can substitute, this we can consider as equation 3, and here from equation 1 and 2 we substitute the values. U is equal to, we will get as UE. UE is of epsilon naught ERMS square. Epsilon is the permittivity, E is the electric field, plus BRMS square by 2 nu naught. This is the formula for the energy density of electromagnetic wave. This is the formula for the energy density of electromagnetic wave. Very important formula. And now, but we know one thing, that we know the energy density of in electric field is equal to energy density in the magnetic field, both are equal. Then from equation 3 we write one thing, that is, from equation 3 we write U is equal to UE plus, here UB is there, but UB is also equal to UE. We write here that 2UE we write, but 2UE, U is equal to UB, that's why we write 2UB. That means the total energy density of electromagnetic wave is equal to 2 times of energy density of electric field or 2 times of energy density of magnetic field. We know that energy density in the electric field, right? Energy density in the electric field is half epsilon naught ERMS square, or 2 into UB formula we know, BRMS square by 2 nu naught. Then we will get the formula for the energy density of EM wave is, this is cancelled, and then we will get epsilon naught ERMS square. Epsilon naught ERMS square, or it is also equal to BRMS square by nu naught. Brms square by nu naught. What is this? This is the formula for the energy density of EM wave. What is U here? U is the energy density of EM wave. Energy density of EM wave. Okay, right. What is epsilon naught? Epsilon naught is the permittivity of free space. Permittivity of free space. Permittivity of free space. What is nu naught? Permeability of free space. Permeability of free space. What is ERMS? Electric field intensity, RMS electric field intensity, and RMS magnetic field intensity. Okay, and magnetic induction. Then ERMS we write as ERMS is equal to, we write as E naught by root 2, and IRMS is equal to, BRMS is equal to, we can write as B naught by root 2. Okay, right. And now this is about energy density of EM wave. EM wave energy density means we have to add the energy density of electric field and magnetic field, then we will get the EM wave energy density. Okay, right. Take the screenshot and note it. I am going to rub it and then I will continue the next topic, that is show that average energy density in electric field is equal to the average energy density in the magnetic field. That I am going to prove. Okay, let us go for the next topic, and this is also very important. That is one question, right? It is the previous CBSE 3 marks question. Show that average electric energy density is equal to the average magnetic energy density. We have to show that average electric energy density is equal to average magnetic energy density. Then how we can show that electromagnetic wave energy is equally distributed among the electric and magnetic fields? Then average electric energy density formula we know, that is average electric energy density. Average electric energy density. What is that formula? Average electric energy density formula is U suffix E, that we know as of epsilon naught ERMS square. Okay, this we know. This is equation 1. Average magnetic energy density I want. What is average magnetic energy density? Magnetic energy density. This formula is already you know, that is average magnetic energy density is energy stored per unit volume. Magnetic energy per unit volume is called as magnetic energy density. That formula is BRMS square by 2 nu naught. This is equation 2. And now I am going to prove this. These two are equal. Show that average electric energy density is equal to the average magnetic energy density. We have to show that U is equal to UB. Then for that purpose what we have to do? Then we know that speed of EM wave what do you know speed of EM wave formula? That we know as ERMS by BRMS. Okay, from this we write ERMS formula as C into BRMS. This is equation 3. Now what I have to do? Now I will substitute the equation 3 in equation 1. Okay, equation 3 is substituted in equation 1. Okay, equation 1 is what? Electric energy density, right? That is UE is equal to of epsilon naught into ERMS. This is epsilon naught. ERMS we write here. This is ERMS. ERMS we write as C into BRMS. C into BRMS whole square. This we have to simplify. That is UE is equal to half epsilon naught into C square into BRMS square, right? Okay. But one thing you know, that is electric energy density is equal to half epsilon naught into C square formula we know. C square formula we know, that is speed of light formula in terms of permeability and permittivity. That is C is equal to 1 by under root nu naught epsilon naught. This we know already in the previous topic. This C square we want. C square we write as 1 by nu naught epsilon naught into BRMS square we will get. And here epsilon naught will cancel, then UE is equal, we will get as BRMS square by 2 nu naught we will get. This is what from equation 2. BRMS square by 2 nu naught is UB. That means we write UE is equal UB we write. This is equation 4. Right, the proof is completed. This is from equation 2 I am writing. That is electric energy density equal to magnetic energy density. That is only they are asking the question, that is show that average electric energy density is equal to average magnetic energy density. The proof is completed. Very simple, right? Okay, let us see next topic, that is intensity of EM wave. What is intensity of EM wave? Intensity of EM wave or the energy flux. That is the energy of EM wave. The energy of EM wave per unit area and per unit time is called as intensity of EM wave. This is called as intensity of EM wave. What is intensity of EM wave or energy flux? Intensity of EM wave is equal to, we can consider intensity as I. This intensity is equal to energy of EM wave per unit time and per unit area. That means that is time into area. Okay, this is the formula for the intensity. And this energy by time is also we write as work. Energy equal to work by time. Work by time is the power. We write this as power by area also. Power by area. What is its SI unit? Its SI unit is power by area. Power unit is watt and area unit is meter square. We write its unit as SI unit is watt per meter square. Watt per meter square. Okay, right. Power unit is watt and area unit is meter square. Watt per meter square. It is the unit for the intensity of EM wave. Okay, I am going to derive the formula for the intensity of EM wave. We know that energy density of EM wave. Yes, energy density of EM wave is we know. What is energy density of EM wave? I want the intensity of EM wave here, but I know energy density of EM wave. What is energy density? Energy density is equal to energy by volume. Yes, energy by volume. This is the formula, the energy density of EM wave formula we derived previously. That is epsilon naught ERMS square. We know energy density of EM wave is UE plus UB. EM wave means it has electric and magnetic. Two are there. We have to add both energies. Then the EM wave energy, but these two are equal. That's why UB we write UE. Then we will get the 2 UE. But energy density in the electric field formula is half epsilon naught ERMS square. then 2 cancel, then you will get U is epsilon naught ERMS square, right? And here energy density of EM wave is energy by volume. Its formula is epsilon naught ERMS square. Okay. Now what I am going to derive? I am going to derive the formula for the intensity in terms of epsilon naught and ERMS. And for the purpose what we have to do here, and energy density is the energy by volume. Energy by volume we write is length into area we write. Okay, volume we write is length into area, that is equal to epsilon naught ERMS square. And the next step I will write like this, energy by this length we can write as speed into time. Length we can take as distance. Distance is traveled by the electromagnetic wave, and that is equal to speed of electromagnetic wave into time we write, CT we write. CT into A we write. And this is equal to epsilon naught ERMS square we will get. In this you see energy we got here, here we got time, here we got area. This C we can take to right side. Okay, then we will get energy by time into area we will get. Its formula what you will get here, epsilon naught ERMS square into C we will get, right? This is what, this is intensity, right? This is the intensity of EM wave. Intensity of EM wave is equal, we got epsilon naught ERMS square into C. This is the formula for the intensity of EM wave. Intensity of EM wave. This is the formula for the intensity of EM wave. What you see in this, epsilon naught is the permittivity of free space, and ERMS is the RMS value of electric field. RMS value of electric field. RMS value of electric field. C is the speed of EM wave. Speed of EM wave. From above figure we write one thing, that intensity of EM wave equal to average energy density of EM wave into speed of light, right? We can write one equation from that, that is intensity of EM wave is equal to, intensity of EM wave is equal to, what do we write? Energy density of EM wave, energy density of EM wave into speed of EM wave, right? Speed of EM wave. This is epsilon ERMS square is the energy density of EM wave. C is the speed of EM wave. This is the intensity of EM wave. This is the formula, right? Okay. This is about intensity of EM wave or the energy flux. Take the screenshot and note it. Next topic I am going to explain what is the momentum of EM wave. Momentum means if any object moves with certain velocity, that object has momentum. That momentum is the product of mass and velocity. But electromagnetic wave is the radiation. This radiation also has the momentum. What is the momentum of this one? When the electromagnetic wave passes, okay, and if it is incident on certain surface, it can transfer the certain momentum to that object, and it can apply the force on the object, it can apply the pressure on the object. And now what is the momentum of EM wave? That I am going to find out. We know that is a momentum of EM wave formula is momentum of EM wave. It was very simple to write. We write like this, the momentum we can take as the P, okay, and momentum of EM wave equivalent mass. For example, energy of EM wave we write as mc square, right, equal to mc square. Energy is equal to mc square we write. You see here, we know that energy is equal to mc square. Okay, first I will write here. We know energy formula, right? mc square. Energy of EM wave, we write mc square. Equivalent mass of EM wave is m. And here we write, this is from Einstein equation we write. This we write as mc into c. This energy of EM wave, energy of EM wave is equal, this mc we can take as equivalent to momentum of EM wave. Momentum of EM wave into speed of EM wave. Speed of EM wave. Then from this we write the momentum of EM wave, right? Momentum is equal to, we write as energy by energy of EM wave by speed of EM wave. Speed of EM wave. This is the formula for the momentum. The momentum P we can write as energy. Energy formula, we know intensity is equal to energy by time into area. Time into area. If you want from that, if you want the energy formula, we take time into area to left side. We will get ITA by speed is c. This is the formula for the momentum of EM wave, where I is the intensity of EM wave. Intensity of EM wave. T is the time. A is the area. And C is the speed. Speed of EM wave. Okay? Right. This is about momentum of EM wave. Take the screenshot and note it. I will rub and continue, and one more last topic I will explain. Okay, let us go for the last topic in the electromagnetic wave. That is the electromagnetic wave incident on non-reflecting and reflecting surface. Right. Firstly, when the electromagnetic wave incident on the non-reflecting surface, what happens? When the electromagnetic wave incident on the reflecting surface, what happens? That we are going to discuss. For example, it is a polished surface. If you throw any ball with certain momentum, if it is polished surface, the ball will be rebounds back. At that moment, what is the change in momentum? If it will goes with P momentum, it will come back with the same momentum P. What is the change in momentum? Initial momentum is P, final momentum is also P, but they are in opposite direction. That's why the change in momentum during the reflection is the final momentum. Initial momentum minus final momentum, right? Or the final momentum minus initial momentum. But these two are in opposite direction. That's why we take one is P and the other one we will take as minus P. That's why we will get the change in momentum as 2P. But sometimes if it is a non-reflecting surface, for example, I thrown the ball and the ball is attached to the surface. That means after hitting, its momentum becomes 0, its velocity becomes 0. It will stuck up to the wall. It is a non-reflecting, it is not reflecting, it is not bouncing the ball, right? And at that moment when the ball, initial momentum is P, but after striking the wall, the ball is stuck up to the wall. That means its final momentum is 0. In case of, in that is called as non-reflecting, right? And then for that, the initial momentum is P, but there is no final momentum because finally the ball comes to rest. That is the change in momentum is P. This, how much momentum changes, that much momentum delivered to the surface. Okay. Why the momentum change occurs? Because of when the electromagnetic wave strikes the surface, okay, the same manner, if the ball strikes the surface, then it will apply the its momentum is changing. Then how much momentum changes, that much momentum delivered to the surface, right? That momentum delivered due to the change in momentum, then some forces act on the surface. When electromagnetic wave incident on the surface, then some force momentum is transferred to the surface and some forces acts on the surface, some pressure acts on the surface. That all formulas I am going to derive in case of non-reflecting and reflecting surface. Firstly, the electromagnetic wave is incidenting normally, means at a 90 degree with the surface, on a surface that is a non-reflecting surface, that is a rough surface. Then first point I am going to explain, there is a momentum delivered. Momentum delivered means transferred. Okay, momentum delivered to the non-reflecting surface, right? What is that? Non-reflecting surface. Okay, what happening at here? Non-reflecting surface, the EM wave with momentum P, it is incidenting on the surface. After that, this surface completely absorbing that electromagnetic wave. The electromagnetic wave is not reflecting back, that's why the final momentum becomes zero. Then what is the momentum delivered? That is equal to change in momentum, initially P for the electromagnetic wave, but after striking the electromagnetic wave, momentum becomes zero because this surface completely absorbs the EM wave. That's why EM wave does not have any momentum. There is a momentum delivered is equal to, right, momentum delivered is equal to only initial momentum, right? Then we write the momentum delivered, okay, that is equal to momentum delivered, we can take as P, okay, that we write as initial momentum only, that we write as energy by time. Energy by time. Momentum formula we know already, energy by speed of EM wave, not time. Energy by speed of EM wave we know. Then energy formula is we know ITA, yes, already previously we discussed. Energy equal to intensity into time into area by speed is C. Okay, because we know formula, that is energy is what we know, intensity is equal to, we know, energy by time into area. Time into area we know by using that formula. This is the momentum delivered formula. Okay, right. The second formula I am going to explain, force on non-reflecting surface. How much force it is applying, right? The force is equal to rate of change of momentum. Force is equal to rate of change of momentum. This is the momentum. By its time we have to do, just we have to find out from above equation, P by T we can calculate. Okay, dP by dt, it is nothing but P by T. That is, what is P by T at here? This momentum by time we have to write here, that is A by C we will get, right? Just you take this 2 to left side, then P by T we will get, where the P is the momentum, that is we will get as IA by C. IA by C, directly I will write it here, that force formula, you momentum change in momentum, this is the change in momentum dP, this one actually. Okay, momentum delivered, change in momentum delivered, that is equal to ITA by C. Then change in momentum by time we have to calculate, then we will get IA by C. This is the formula for the force. Next I want the pressure on non-reflecting surface. When electromagnetic wave incident on the non-reflecting surface, how much pressure it can apply? Then we know the pressure formula as force by area. Don't confuse the pressure and momentum and pressure, both are different. Force by area, here we got the force formula, that you should divide with the area, then I by C we will get, that is the formula for the pressure on surface is intensity by speed of EM wave. This is the momentum delivered, force on non-reflecting and pressure on non-reflecting surface. When EM wave incident on the non-reflecting surface, how much momentum transfers, how much force applies, how much pressure applies on the non-reflecting surface we discussed. And the next one is the same electromagnetic wave is incidenting on the reflecting surface. When electromagnetic wave is incident on the reflecting surface, with how much momentum it is incidenting, with the same momentum it goes back, because it is a reflecting surface. During this, what is the change in momentum? In this case, what is the change in momentum in this case? change in momentum is the final momentum minus initial momentum. For example, while going, if you take it as plus, and while coming you take it as minus, then the final momentum minus initial momentum, or initial momentum minus final momentum, we will get the change in momentum as 2p, 2 times of initial momentum we will get, right? I want the momentum delivered is equal to change in momentum. Momentum delivered, large change in momentum occurred. Here the change in momentum is initial momentum p, final momentum is 0. That's when the change in momentum is equal to p minus 0, we will get p. That is the momentum of EM wave we will get. But here momentum delivered or change in momentum. Momentum delivered to reflecting surface or the change in momentum of EM wave, that we will get as dp is equal to, we know the change in momentum is 2 times of the momentum, 2p we will get 2p. What is p? Momentum of EM wave, we know that is energy into 2 into energy by speed. Okay, here the change in momentum is only p, that's where we write energy by speed, but here change in momentum is 2p, 2 into energy by speed. That is the change in momentum. dp is the change in momentum. Okay, remember it. Momentum delivered, dp is the momentum delivered, that is 2 into energy, we know already, ITA. From that I equal to energy by time into area, from that energy is equal to ITA, we write ITA by C. This is from energy equation, right? Energy, what you know, energy of EM wave, that is equal to, sorry, not energy, and that is from intensity equation, we know that is intensity is equal to energy by time into area, from that energy is equal to ITA. Then we will get finally, this is the formula for the momentum delivered. This is the momentum delivered. dp is the momentum delivered or the momentum transferred. Momentum delivered or the momentum transferred. And let us go for the force, second point, the force on reflecting surface applied by EM wave. Force on reflecting surface. What is the force? Force on reflecting surface is the force is equal to, we write as dp by dt, we write. Okay, here we got dp, by you have to divide this with time, then we will get a 2ia by c. Just that in that equation you have to divide this equation with the time. Here we know dp, this t taken to left side, then the dp by dt, we will get the force formula is 2ia by c. The third equation is the pressure on reflecting surface. When EM wave incident on the reflecting surface, how much pressure it can apply? The pressure formula we know as force by area. We know here force, you divide with area, here area A is there, you divide this, you take this A to left side, F by A we will get, that is 2I by C. This is the formula for the pressure exerted by the EM wave on the reflecting surface. When EM wave incident on the reflecting surface, this is the formula for the pressure, this is the formula for the force, this is the formula for the change in momentum delivered. Okay, note every point, take the screenshot and note it. If you have any doubt, you can ask me. Thank you. Till now, if you not subscribe my channel, subscribe and share to your friends.